Hey, John here. So last time we left off with a code walkthrough of how to light up a single digit on a sign. Now we're going to light up all the digits and we're going to make a timer. This timer will count down instead of up, and it will have multiple digits. And on my sign in particular, the digits all have different number of LEDs in them, or at least one of them has a different number of LEDs than the other. So I have to create a way to write to some LEDs one way and other LEDs a different way. So I also have two colon dots in the middle of the series of all the LEDs as we go through the numbers. So what I've decided to do is I create this structure here that represents a descriptor for each one of the LEDs. Within this structure, I'm going to have the starting LED number address. Like the very first LED that counts the tenths will start at address 0 because it has the first LED in the entire series of all the strips combined. The number of strips within the 7-segment LED segments, within the segments. So the first LED has 1 strip per segment, and all the other ones have 2. The number of LEDs per strip. The first LED in my sign has 2 LEDs per strip, and all the rest of them have 5. So I'm going to then create an array of these descriptors. So the first LED right here starts at 0. It has 1 strip per segment with 2 LEDs per strip. The next one starts at 14 because this has got 2 times 7 total LEDs in it. So the next display will start at 14. It has 2 strips with 5 LEDs per strip. This then has 70 total LEDs in it. The next digit would therefore start at 84, and it has a 2x5 which has another 70 LEDs in it. The next one after that starts at 156, which you'll notice is 2 more than you'd think because the 2 colons are sitting in there, right? So it goes digit, digit, digit. Then we'll have these 2 colons, and the colon addresses are 154 and 155. Then 156 will be the first address of the LED in the next digit, which is a 2x5, and so on for the last one, which is another 2x5, starting at address number 226. Therefore, the total number of LEDs in the whole sign for me is 296. I create my NeoPixel strip just like we did before. The only difference here is that we have more LEDs. The setup, no difference. The next in the counter is really no difference, except when I do the reset, I'm going to count down instead of up. So when I reset my counter variable, I give it a big number instead of 0. And for fun, I'm going to just start it with 3 seconds so that it can count down and show me my end of counter screen quickly. Normally I would run it for 3 minutes. That's my target. I want a 3-minute timer that ends with like a flashing red display to let me know that it has ended. So for testing, I'm going to just count down 3 seconds and flash it, so I don't have to wait very long. The Luma is the same as before. The colors are basically the same. I renamed the foreground and background colors because I'm going to play a little bit of a game. When I noticed before is that the colon dots and the little tenths digit are a little darker than the bigger digits are. So what I've decided to do is create 2 different foreground colors. The foreground color for the 1 strip LEDs, which would be the colon dots and the tenths digit, I'm going to actually make brighter than the 2 strip LEDs so that they all look about the same. That's the really reason I got foreground 1 and foreground 2 for 1 strip and 2 strips. I have a red color that I've defined so that when the sign runs out, I'm going to put red up there. And the background color, I just changed to black color. I also created a macro to remember what number in the font table to use to put a dash on the screen. So what I'm going to use that for is when I count down to 0, I'm going to just put a bunch of red dashes on the display. That's why I did that. Okay, so what changed? The real changes are in the loop function and in the digit function, okay? And that's it in order to make this work. So let's see what happens here. I'm now going to count in tenths instead of whole seconds because I want the little tenths digit to count in, as you think, tenths. This will come into play when it runs out to 0. I'll talk about that in a minute. The rest of this is basically the same thing. We got the usual game. Wait until the time expires based on the period. And when it does, this is the same as it was before. I'm going to advance the period based on the this variable here, but I'm going to go faster than I did before. When I'm 0, this is going to flash a red pattern. I'll talk about that in a minute. When I'm not 0, I'm going to count down instead of up. And this is how I decide what to put on each one of the digits. And this lights up the colons. I simply call the set pixel color directly in here, and I just use the single strip color that we just talked about for the 2 colons. When I'm done with all that, I call show, just like I did before. So what's the difference here? Okay, so I need to light up multiple LEDs, and each LED I have to put the correct value on. So this counter is going to just count, whatever, for 3 seconds. That's going to be like 300, right? Or 30. Where's my initialization? I'm counting in tenths. I lost it here. I'm counting in tenths. Wow, I can't even find, where's my counter? There it is. Counter reset, it's right here, 3 times 10. So I'm going to count from 30 down to 0. That's what I wanted to see, for crying out loud. So the first time through here it's going to be 30. The second time through here will be 29, and so on. So how is that really going to work? Well, counter mod 10 will simply be 0 through 9, 0 through 9, 0 through 9 as we come through here, or more accurately 9 through 0 since we're counting down. The seconds value would be divide the counter by 10 modulo 60, right? So we divide it by 10 because the tenths over here consumes the first 10 values, or the least significant digit in decimal. The minutes is similar. We say a counter divided by 600 because there's 60 seconds in a minute, and there's 10 tenths going on in the tenths digit. So I have to divide this one by 600. Again, modulo 60 because there's 60 minutes in an hour, 60 seconds in a minute, and so on. So that's the math in here. When I set the digit values, what I need to do is I say, well, okay, the most significant digit, 0, 1, 2, 3, 4. This is all 5 of my LEDs. The 5th one to the far left needs to have the value. This is the number to put on the digit. Would be the minute value divided by 10 because it's the most significant digit. And then I ask, by the way, if the minutes divided by 10 is 0, I'm going to make it black. So it won't say like 03 on there. It'll just put a blank and a 3. So it won't have a leading 0 in the minutes section. That's what this is doing over here. If it does have a value that's not 0, it sets it to the 2-strip foreground color. Same kind of logic goes on down here. Minutes modulo 10 would be the least significant decimal digit. Put that in the LED number 3, foreground 2-strip. And seconds over 10 would be the most significant decimal digit of the seconds value for the next digit, and the least significant decimal digit, and the tenths. The only difference here is I use foreground 1 because the tenths digit has a single strip in it. Okay, this is how we count and how we set multiple LEDs with the correct value given a single counter. When the counter runs to 0, I don't do this down here. I play this game up here. This is where this pattern comes into play, and I want to flash a bunch of red dashes on the screen is what I want to do. So how does this work? When the counter is 0, I want it to stay at 0. So inside here, we never advance the counter, all right? You'll see that it's stuck down here only when we're actually counting the time down. In here, I'm going to increment pattern. This math here creates a 1 to 5 duty cycle. I only want it off 1 out of every 6 ticks of time and on the other 5. So how does that work? Pattern over 3. Remember, this logic is counting. It gets executed 10 times a second because that's the timer period as I leap through time. So every 3/10 of a second, I'm going to ask, is the value mod 6 equal to 0? So that's 1 out of 6 times. I'll set it to black. The other 5 will be red. Okay, if you don't believe me, go ahead and do some serial printing and watch the value over time when you run your code on your Arduino. So once I've decided what the color is going to be, I just simply put the dash character on the 4 big LEDs. I make the little one blank because it looks weird having a dash on the little one. And I light up the 2, or I actually want to shut off the 2 colons in this particular case. So all I'm going to see is just a couple of dashes, and that's it. And it'll flash every now and then. Dividing this by 3 slows down the flashing essentially. The bigger this number is, the slower it will go. I slowed it down so I don't give myself or somebody else a seizure with all kinds of crazy flashing. All right, so that's the new loop logic. Let's look at how the digit has to work. Now, we use the descriptors I just talked about to make this work. This part and the font, all that game is the same. The digit now has a place. Before it just had the value, the face value, and the color. Now it has a face value that I should put, and the place for that face value is also passed in. So how does this then work? I go, well, I want to know what the descriptor is given the place, right? Remember when we call this, for example, digit 0, digit 1, digit 2, digit 3, and so on, those index through the descriptor array, where I can then get the starting LED number, the LEDs per strip, and the number of strips per segment that we already discussed up on the top of the file, all right? So I assign it to these variables so that they are reasonable names, and I can use them in the code down here. So I have, that's where I find the information about the geometry, what I like to think of as the geometry of each one of the digits. I now added this inside loop. The outside loop, 0 up until 7, and you shifting right, 1, and so on. I discussed all that in the last video. The new part for this video is this new for loop here. Because I might have 1 strip or 2, or I could have 7 strips if you made a giant one, right? I have to iterate through another loop in here once for each strip, which I grabbed from the descriptors, all right? This code right here exists to calculate the number of the strip that begins this segment up here. Remember, this iterates over the 7 segments, 0 through 6. This is going to iterate over the number of strips within a segment. In this case, it'll either be from 0 to 1, 0 a single time through if it has 1 strip, or it'll go 0 and 1 in my case because I have some with 2 strips. So let's look at the case for the 0th strip. Strip number, okay, this variable will get set to, in a single strip case, I want it to be 0, 1, 2, 3, 4, 5, or 6 like this, okay? How does that then work? So I got J mod 2. Well, if J mod 2 is 0, which it is in the first, 0 mod 2 is 0, that's false. So it uses this value here, which is J, which is 0, times 7, which is 0, plus K, and it puts that into the strip number. That gives me strip number 0, which is actually what I want for the 0th strip on the 0th segment and the 0th strip. It should be 0. So that now says, give me the starting LED, which I got from the descriptor, plus the strip number, which I now know is going to be 0 the first time, times LPS, which is 0. So the starting LED is 0, plus 0 is 0, which is exactly what I want for the first strip of the first LED and the first segment. All right, so that works for that case. What about the rest of them? Well, it turns out the very first LED, the 7-segment 10th LED, only has 1 strip. So this code is logically equivalent to what you saw in the last program for that first LED. 0, K becomes 1 for the second one. We do the 0th strip, which means we are executing this again. So now I end up with 1 times 7, which is 7, plus K times LPS, and that is, if you look in here, you'll see the same code before, which was the 7 plus K times LPS. So that works out fine. What if we have 2 strips? Okay, the second LED over, the descriptor for place number 1, remember, has a starting number of 14. LEDs per strip is 2. Number of strips, or rather LEDs per strip for the second digit is 5 with the 2 strips. Okay, so now it will start at strip number 0, and it will play the same game over here and do the same thing it did for the first LED, but the starting LED number now was 14. So I got 14 plus the strip number, which would be 0 for the first one, times LPS is 0. So the first strip of the second LED starts where the first LED ended off at 14. That works perfectly. Again, all the same stuff over here in this setting of the segment, that's all the same as the last walkthrough. So we can then look at the second strip. This is where it gets interesting. All right, I'm at LED number 1, place number 1. The starting is 14, 5, and 2. Right? So I'm in the second iteration of this inner loop for segment 0. This means J is equal to 1. 1 mod 2 is now 1, which is true, and I'm going to use this math in here. So J is 1 plus 1 is 2 times 7 is 14 minus 1 is 13 minus the K, 0. Okay? This is because when I wired up my LEDs, the first strip went around this way, and I can call that forward, logically. The second strip went backwards like this, as you might recall, all right? So if we call this one 0, 1, 2, 3, 4, 5, 6, the backwards one would be 7, 8, 9, 10, 11, 12, and 13. So this very strip over here, 0 and 13 go together. 1 and 12 go together, and so on. So in order for that to work, and I want to light up the very 0th number segment, I need this to be 0, which it was. We just went through that. And I need this to come out to be 13, which it does. So J plus 1, in this case, is 2 times 7. That is 14. Minus 1 gives me the 13 that I want. Minus the K, which is 0, because I'm still doing segment number 0. This gives me the 13 I'm looking for. So now that is actually strip number 13 of the total number of all the strips inside that digit. So it's the starting LED, which is 14 plus 13 times the number of LEDs per strip, gives me then the address of the first LED of that second strip that makes up segment number 0. This math continues on for the first segment and the second segment and so on. That's how we do the 2 strips. 3 strips, if you had 3 strips in here, you'd be forward on the first strip, backwards on the second strip, forwards on the third strip again, all right? So it makes sense that you would see this backwards counting logic for the odd numbered strips and the forward logic for the even numbered strips, and that's what this whole math does. That's it. That's the whole ball game for multiple digits with different geometries, all on one sign and the colon. And when it runs out in time, I want to flash red bars, red dashes across my screen. This would be the final code. Let's run it, see what it looks like. Now you can see it's counting down. In the test mode, it only counted 3 seconds. Now I got my flashing red dashes. And you'd think everything is hunky-dory except for one problem. We will discuss that problem in the next video. We just need to, roll up our sleeves and do a little bit more tinkering. I'll see you next time.